Hello. Learning to translate policies into modeling parameters is essential for creating scenarios to inform policymakers. This exercise will explore how to translate a set of policies into modeling variables. We're going to locate ourselves in Wakanda. Wakanda Generation Expansion Plan aims to increase the deployment of solar generation technologies into the system's power matrix. The creation of this generation expansion plan involved various participatory workshops in which sectoral experts, policymakers, and social society members proposed deploying more solar power technologies. With the insights from participants, the Energy Secretariat proposed generation targets for three different solar technologies: utility scale PV with 2 hours storage, solar PV in utility scale without storage, and distributed solar PVs. The objective is that at least the percentages are reached in the established years, assuming a progressive growth until reaching the goals that are shown in this figure. So we have these specific percentages for these specific technologies, and we are going to have, for example, 0% of utility scale PV with 2 hours storage in 2023, and it is going to grow to 10% in 2030 and 18% in 2050. Also, this expansion plan aims to promote power autonomy and establishes a decrease in electricity imports until reaching in 2050 35% of the value of imports in 2023. The Ministry of Environment created a model with multiple scenarios, and they want to incorporate an additional scenario that considers the least cost scenario and the goals established in the expansion plan. The least cost scenario will reflect the optimal energy system configuration under which the cost is minimized. Take a few minutes to think how to model these policies. For this specific exercise, we're going to use the Wakanda model. In the description of this video, you can find a Zenodo link. So you can go through that website, download all the files, please save all the files in the same folder, and just be sure that you are in the most recent version because we can do some updates. We're going to start with policy number 1, the deployment of photovoltaic generation. Remember that we always need a balance between generation and consumption in the electricity systems. So in this specific policy, we can use the specified annual demand to calculate the production from the technologies of interest by simply applying the percentage of participation defined in the policy. In this clicSAND file, there is only non-zero specified annual demand for commercial, residential, and industrial electricity consumption. Therefore, the aggregated yearly demand for these fuel types will be used to calculate the values for the total technology annual activity lower limit. Nevertheless, an important consideration is that there are losses in the electricity system, therefore, we need to consider them when we define the total technology annual activity lower limit of each technology. In this way, the final electricity consumption plus the losses of the electrical system will give us the minimum electrical energy that the electricity system has to generate to satisfy the demand. To solve this problem, we need the following information: the specified annual demand of the three different fuels that we already saw, for example, industrial, residential, and commercial. Also, we need the input activity ratio and the output activity ratio of the transmission lines technologies and the distribution line technologies. Also, we need to modify the total technology annual activity lower limit of the three solar technologies of interest. And we always need to check the total technology annual activity upper limit of the technologies that we are going to modify. Remember that the demand divided by the efficiency give us the generation, and this efficiency considers the whole system efficiency. So it's considering also the efficiency of the transmission lines and the distribution lines, which is given by multiplying the transmission and the distribution efficiencies. Please go to the Wakanda data file and copy and paste all the required information. I already did that. And for example, as you can see, I copied the specified annual demand for the three different fields of interest for the whole time horizon. So we need to do this for all the relevant information. For example, I also included the output activity ratio of the technologies that are related to the distribution lines and the transmission lines. I also copied the total technology annual activity lower limit of the three technologies of solar generation. I copied the total technology annual activity upper limit. We need to check these values also for the three different solar technologies that we're going to modify. So copy and paste all of this information because we needed to do all the different calculations for the modeling parameters. As we saw in the presentation, to assign the generation percentages to renewable technologies, we need to calculate an approximation of how much electrical energy the country needs to produce to satisfy the demand. So we will sum up the industrial, residential, and commercial electricity consumption, and then we're going to consider losses. So first, let's sum all of this bills for the whole time horizon. And then we need to calculate the total available energy for distribution and the total available energy for transmission. So we're going backwards from the demand to the generation. And what we're going to do is divide the demand by the efficiency. This for the whole time horizon. And then we're going to do the same process with the available energy for distribution. We're going to divide it by the efficiency of the transmission lines. So this is the electricity that at least we need to generate to satisfy the demand using the total technology annual activity lower limit. The table that is shown right now is the policy that we need to model. And as you can see, we only have values for 2030 and for 2050. But the policy mentions progressive growth. So it is enough to make a linear projection between these years to determine the percentage of generation of each technology in intermediate years. So what we can do next, we can do, or we can use the forecast function of Excel to calculate this whole information. So using the forecast linear, we can fix this value, then use the known y's, and we are just fixing the columns, and then the known x's, and we have to fix both rows and columns. Now we can multiply these by the specified annual demand that we have, not the specified annual demand, sorry. We can multiply these by the total available energy for transmission, that it's going to be the total generation that we need. And we specifically need the value in 2024, and we need to fix the row. So now we can calculate this for the three technologies, and then we can forecast it to 2030, and then we can copy the value from 2031, but just we need to change this. And now we can do the same process and do this for the whole time horizon. This specific model only has information from 2015 to 2050, and you can check this also in the specified annual demand. So don't worry about those zeros that you can see, because the model is just from 2015 to 2050. Now, all of these are the new total technology annual activity lower limit of the specific technologies that we are going to modify. So later we have to change these values in our Wakanda file. Now we're going to focus on policy number 2, which corresponds to power autonomy. This policy can be modified using the Total Technology Annual Activity Lower Limit and the Total Technology Annual Activity Lower Limit. Please go to your Wakanda data file and copy and paste the value for these two parameters. Just be sure that you are using the correct technology, and this technology is PWRTRNIMP, and specifically it corresponds to the inputs of electricity in the system. So now what we need to do is calculate the decrease in electricity inputs until reaching the 35% of the value of inputs in 2023. So we need the value of these two parameters in 2023. So we can copy and paste these two values and then just simply apply the reduction that we need. You can copy this in your lower limit. And now we only need to calculate the values in the intermediate years of this time horizon. So what we can do is just copy and paste the values from 2015 to 2023, because we are not doing any changes in these values. And then we can just simply forecast using the forecast function, and we can fix these row, and then we can use these two values that we have here and this one, but we need to fix this data. So once you have the function, you can just apply this to the whole time horizon. Remember that we are only interested in the years from 2015 to 2050, and then you can copy and paste these and just modify the values. And right now we are calculating the lower limit, so you can do the same process and just calculate for the whole time horizon. Great. So now we have our new values. And what we need to do is just copy and paste all of this information that we have calculated into our Wakanda data file. So now we're going to run our model. And to do so, what we're going to do is use Osmosis Cloud. So first, we need to convert this Wakanda data file to a specific input that Osmosis Cloud can read. Remember that there is a clicSAND version 3 that allows us to generate a specific input that can be read with Osmosis Cloud. So we're going to open clicSAND, and in clicSAND, we're going to upload the file that we need to convert. In this case, is specifically this Wakanda solution, and we just need to generate the Osmosis Cloud input. This is going to take a few minutes, and then you are going to read a specific message. When you see that the clicksend is generating the Osmosis Cloud input data, then there is going to be a message that says that the Osmosis Cloud input data has been generated. So once you see this message, you can go to your file, to your folder, and there you're going to see two new files. And the .txt file is the file that you need to upload to Osmosis Cloud. So what we're going to do next is create a new model, and here you can include the name that you want. I have already one specific Wakanda model, so I'm just going to include here version 2. And here you can create a new version of the model. You can name it as you want. This is going to be version 1 of this model. And then we can create our version. So we're going to create a new run. The name is going to be Wakanda, the same one, version 1. And then you can select a specific file. Here we need to upload the Osmosis code. And in the data file, we need to include the file that we have just created. And then you can include a specific description. So this is the Wakanda model with more solar and less inputs, for example. Just something that you can relate with what you are modeling. And then always remember to change the server type. And I like to receive an email. If you don't, you can unselect the specific option. So once you have everything in your Osmosis Cloud, you can create your run. And this is also going to take a few minutes. Then you can start your run, and this will create the server, generate the matrix, for example, and also look for the solution. So we can wait for a few minutes. So a few minutes later, you can see that these models succeeded, and then you can see the steps. So we created the server, processed the data, generated the matrix, solved the model, and then post-process the result. You have here two options. You can see the graphs directly from Osmosis Cloud, or something that I really like is to download the results. And then we can see those results in your desktop. Well, not in your desktop, but in your computer. So you can extract this result.txt file. I am going to save this specific file in the same folder that I am using. So now you can have the file in your folder, and then you can close this, and let's open the folder. So here you can see the result.txt, the specific folder that we have just created, the specific file, sorry, that we have just created. And what we need to do now is convert these result.txt using the Osmosis output converter. So our input file, it's going to be this result txt file. Then you can define your output directory. I'm going to define the same folder, and then you can save the output file name, and then you can run this converter. And after a few seconds, you're going to see new files here. So just remember the name that you have applied. It's Wakanda results. So now you can close this file, and you can open the Wakanda results CSV and the results template where we are going to analyze our results. So here in the results data, what we're going to do is erase all the data that we have and copy and paste the Wakanda results that we have obtained. So be sure that you are copying and pasting all the data. Paste the data in the results template. And then you can go to, for example, annual electricity production, and you can refresh the data and you can see the new results. And here you can see how the solar generation have increased. For example, you have the 3 different technologies that we have created. Also, you can change here and, for example, see the behavior of the inputs, and you can see the decrease in the inputs of your system. So this is a way of seeing the results, of also creating a model, and also learning how to translate policies into modeling parameters. And this is something that you can, for example, then analyze more, change your policies as well, and use this specific exercise to create new policies and implement them with OSeMOSYS. I hope this video was useful, and have fun creating models with OSeMOSYS.